Remember that there are four components of GDP in expenditure approach. We have consumption spending, investment, government spending, and net exports. In macroeconomy, we view the total amount of goods demanded or total spending in the economy as aggregate demand. This is equal to the sum of consumption spending, investment spending, government spending, and spending on exported and imported goods or international spending. Our goal in this chapter is to determine the equilibrium level of output or equilibrium level of income that the economy needs to sustain its level of expenditures. In microeconomics, we have learned that output is at its equilibrium level when the quantity of output produced, which is Y, is equal to the quantity demanded, or Y is equal to AD. Thus, Y is equal to C plus I plus G plus NX also. Whenever output is not equal to aggregate demand, then there is disequilibrium. This means that there is a pressure of the level of production to increase or decrease, or there is unplanned inventory investment. We begin our discussion of income determination model with one sector, meaning we assume that investment, government spending, net exports as zero. So there is only one component of aggregate demand, which is the consumption expenditure. And that is why it is called a one-sector model. Now we will define consumption function. Consumption function describes the relationship between consumption and income. And it is expressed as C is equal to C bar plus C times Y, where C bar is greater than 0 or positive, and the small c is between 0 and 1. C bar here is called the autonomous consumption, or the level of consumption when income or Y is 0. So it is possible that even if the household's income is 0, then still there is consumption, or consumption is positive, because households can borrow and use that amount to buy goods and services. So there is consumption even if income is 0. The small c is called the induced consumption, or the level of consumption that is dependent on Y or income. And it is also called as the marginal propensity to consume. Mathematically, MPC, or marginal propensity to consume, is equal to the change in C, the change in total consumption divided by the change in Y or income. Since small c, or MPC, is between 0 and 1, this implies that every peso increment in income results to less than proportionate increase in consumption expenditure. For example, if MPC is 0.7 or 70%, and the household's income has increased by 10 pesos, then the consumption expenditure of that household is 7 pesos, meaning 70% of the household's increase in income will go to consumption expenditure. So that is the meaning of marginal propensity to consume. We have also the term average propensity to consume, or APC. It is the ratio of consumption to income. In formula, APC is equal to C over Y. The consumption function is more or less depicted in this diagram. It is upward sloping. This means that income and consumption are positively related. The line that divides the whole right angle is called the 45-degree line or the Y line or income line. Its purpose is to help us locate the equilibrium level of income graphically. Let's say, for example, at Y sub 1, the consumption line is above the 45-degree line. This means that households consume more than their income. In effect, saving is negative. On the other hand, at Y sub 2, consumption line is below the income line, or households at this point are consuming below their income level. Thus, there is positive saving. While at Y sub 0, consumption line touches the income line. This means that income of the household is just equal to their consumption expenditures. Thus, saving is 0. The diagram also portrays the equilibrium level of income. It is the point where the consumption of the household is equal to the level of income. And it happens at the point of intersection between the consumption line and the income line, which is at Y sub 0. We will define also the saving function. Saving is income not spent on consumption. So we denote saving as S, income as Y, and consumption as C. S is equal to Y minus C. So from this equation, we can derive the saving function. So substituting C from our equation for consumption expenditure a while ago, so the S equation now is equal to Y minus C. Substituting C from our equation kanina, then S now is equal to Y minus the quantity of C bar plus C times Y. And if we will distribute the equation, so it will become Y minus C bar minus C times Y. And if we will factor out Y here, then it is now equal to negative C bar plus the quantity of 1 minus C times Y. So the saving equation now finally is equal to negative C bar plus the quantity of 1 minus C times Y, where 1 minus C is called the marginal propensity to save. Marginal propensity to save, or MPS, is equal to the change in S over a change in Y. Graphically, we can illustrate the saving function. Just like the consumption function, it is also upward sloping, which means that saving and income are positively related. As seen in the diagram, at Y sub 1, saving is negative, and at Y sub 2, saving is positive, and at Y sub 0, saving is 0, and it is called the break-even point. Notice that at Y sub 0 a while ago is the equilibrium level of income, because again the consumption line and the income line are tangent, or it is the point where the consumption line crosses the income line. So in effect, saving is 0. In my example a while ago, that marginal propensity to consume is 0.7. It follows that the marginal propensity to save is 0.3. The sum of MPC and MPS is equal to 1. So if MPC is 0.6, it follows that the MPS is 0.4. or MPC plus MPS is equal to 1. MPS is also the slope of the saving function. Now, what will happen if C bar or the small c changes? Firstly, suppose C bar increases. Say, there are more donations or borrowings from the side of the households. And to illustrate this situation graphically, we can see an upward shifting of the consumption line. From C bar 1, it is now at C bar 2. So, in effect, the new equilibrium is YE prime. The consumption line shifts upward, but its slope does not change. Now let's evaluate the effect of a change in small c. Suppose small c declines. Let's say there was a change in preferences or tastes of the consumers. So to illustrate this decline in small c is depicted by a downward rotation of the consumption line. So here, the consumption line becomes flatter and its slope changes. In effect, the equilibrium income decreases from Y sub E to Y sub E prime. Let me ask you a question. By how much the equilibrium level of income or output increases if autonomous consumption or C bar of the households increases? I have discussed earlier that as C bar increases, the equilibrium income will also increase. But the question is, how much is the increase in equilibrium income? To answer that question, we will discuss the idea of the multiplier effect. The multiplier is the amount by which equilibrium output changes when autonomous aggregate demand increases by 1 unit. Or in formula, or mathematically, we denote multiplier as alpha, the Greek letter alpha. So the multiplier is equal to 1 over 1 minus c. The multiplier suggests that output changes when autonomous spending changes, and that the change in output can be larger than the change in autonomous spending. Now we will determine the equilibrium level of income mathematically in an economy with only one sector. Suppose the consumption function is given by C is equal to 50 plus 0.8 Y. So this is an example of a consumption function. 50 here is called the C bar, and 0.8 is called the marginal propensity to consume. Recall that to determine the equilibrium level of output or income of the economy, it must be that the output produced of the economy is equal to the output demanded. The question is, what is the equilibrium level of output of the economy if consumption is equal to 50 plus 0.8 Y? So we need to solve this mathematically, and I have already solved the problem, so I want you to take a look on how it is done. So we will now solve the equilibrium income from the given. So first, we let y equal to c, then substitute the c equation, which is 50 plus 0.8 y. The next step is to combine similar terms. So we transfer 0.8 y to the left, and it is now equal to y minus 0.8 y is equal to 50. Next, we will factor out similar terms. So we will factor out y minus 0.8 y. This will become 1 minus 0.8 times y, so which is equal to 50. 1 minus 0.8 is equal to 0.2 y. Then divide both sides by 0.2, so the result will be the equilibrium level of income. So in a one-sector model, the equilibrium level of income in this example is 250. And at that level of income, consumption spending or consumption expenditure is also 250. Okay, you can check that on your own. Then letter B is, what is the value of the multiplier? So solving for the value of the multiplier, we will now use the formula, which is alpha is equal to 1 over 1 minus c. So if we will substitute, magiging 1 over 1 minus 0.8, which is equal to 1 over 0.2. And 1 over 0.2 is equal to 5. This means that for every peso increase in the autonomous spending, which is in our case the C bar, equilibrium income will also increase by 5 pesos. So that's the multiplier effect. Letter C, by how much does a 10 peso increase in autonomous consumption raise the equilibrium level of income? So in letter C, it says that autonomous consumption or C bar increased by 10 pesos. So from our consumption function, 50 plus 10. So the autonomous consumption is now 60 pesos. So the new consumption function is now C is equal to 60 plus 0.8y. Okay, so we will solve the new equilibrium as autonomous consumption rises by 10 units or 10 pesos. So again, the same process. First, we will let y equal to C. So C bar again is equal to 60, and the new consumption function is now C is equal to 60 plus 0.8y. Then substitute the new consumption function. So y is equal to 60 plus 0.8y. Then the same process as before. So the new equilibrium is now 300 pesos. Ibig sabihin, the equilibrium level of income has increased by 50 pesos. Diba? From 250, it is now 300. And another way to solve for the change in the equilibrium level of income is by using the value of the multiplier. Earlier, we have computed the value of the multiplier, which is 5. And the change in autonomous consumption is 10. So if we will multiply the value of the multiplier and the change in C bar, so that is now equal to the change in the equilibrium level of income. So 5 times 10 is 50. So the effect of the increase in autonomous consumption or C bar is the increase in the equilibrium level of income by 50.